Hello, everyone. Thank you for joining us at Cribble today for the first webinar in a series about observability best practices. Today's webinar will focus on building an observability pipeline. During the webinar, we encourage you to ask questions using the Q&A button at the bottom of the console. We'll have time at the end of the presentation to answer your questions. We'll also be recording today's webinar and we'll send a link to the recording when it becomes available. So please check the email account that you used to register for the event. For information on upcoming events, please check cribble.io/events. I would now like to introduce today's speaker. Clint Sharp is the CEO and co-founder of Cribble. Clint, I'll now turn over the presentation to you.
Thanks, Brian. And thanks everybody for attending. Your time is very valuable and we really appreciate this opportunity to talk to you about what we're seeing in the marketplace. From an agenda perspective, we'll talk a little bit about kind of the overall space and how we see the market transitioning into the specifics around observability and some of the challenges we see in observability and security. And lastly, we'll end with how we believe we can make that better with our product LogStream, which is an observability pipeline. To start with, talk a little bit about who am I. I'm currently leading Cribble, co-founder and CEO. We are a streams processing engine for logs and metrics. I've been a practitioner. The first decade of my career was in IT operations and network engineering. My last role prior to coming to the vendor side was as director of application operations at Cricket, up to the late, ending in the kind of early 2010s. Running large, complicated distributed systems. So I've certainly seen this from the practitioner side and running IT operations and complex distributed systems. That led me to the vendor side where I joined Splunk about 8-9 years ago, built and launched a number of products for them. Cribble's about 3 years old. We founded the company in 2017, and we've been working on solving some of what we think are the most interesting challenges in the world today. So today, what you should leave understanding is what is observability and why are we looking at new tooling? What has changed that's requiring us to change the tooling that we've historically had? Also, what is changing about the security landscape and why do we need new tooling there? Now, part of what we solve is these new tools are creating new challenges that require integration, help us manage costs. We'll talk a little bit about some of the problems that those are creating. And then lastly, we'll hopefully you should leave with an understanding of what is an observability pipeline and how does it address those challenges. I always like to put a summary at the front. Perhaps you, like me, are also busy and you just like to know what is it we're going to say. And then hopefully at the end, as we recap this, you'll understand in more detail what exactly we're saying. So summary-wise, enterprises need a ton of tools, and that's not getting any better. These tools are big data systems in their own right, receiving, storing terabytes and petabytes of data daily. This tooling is incredibly expensive, costing millions upon millions of dollars, and an observability pipeline allows us to process that data for observability and security tooling before storage, potentially saving millions and simplifying complexity. So dating myself a bit, all the systems over at the left I actually worked on at one point in my career. As I emerged, and I'm ignoring kind of the mainframe because that came a little bit before my time. Obviously still a lot of mainframes out there, not diminishing their role. I know they process the majority of the world's financial transactions, but most application development is the time I emerged into the industry, especially in larger enterprises, were based on kind of big iron. Like I worked on an HP Superdome. I worked at AT&T Wireless in the early aughts. Our Superdome was the only box we could find that had 128 processors in a single system image. And so it was, we used that for doing all the cell phone mediation, where if we fell behind, like we were losing millions of dollars an hour because we had no way of catching up. That machine was already running at 70-80%. And if we fell behind, there was no catching up. And during those days, the way in which we did troubleshooting was, there was some grisly Unix sysadmin sitting in a back closet somewhere SSHing in and using his standard tool set, tail, grep, looking through logs, trying to understand configurations, running top and PS, and trying to figure out, which processes were chewing through resources, and sort of all was well with the world, at that point in time. But probably 10 years ago, a little bit more, maybe more like 13, 14 years ago, we started to see the strong advent of service-oriented architecture, and that's where most applications started to move distributed. Now, they may have been monoliths. We may have been deploying a monolith across, in number of instances of that monolith. That led to a number of building and testing challenges, which then sort of begat microservices. And now in the world in which we are finding ourselves in today, for online properties, they may have hundreds or thousands of microservices having large amounts of emergent behavior that is incredibly difficult to troubleshoot, and no longer can one person SSH into a machine and use their standard tooling to go introspect these systems and understand their operation. And so we're sort of in a world where we've lost the ability to understand and reason about the systems that we're building and running. And so what we really need in today's world is an ability to troubleshoot modern architectures in the way in which the old Grizzly Unix sysadmin was able to do, 20 years ago. So that's where you start to see the advent of the term observability. And so observability, our definition, there's a lot of definitions of this, and I don't like to get into sort of the religious nature of observability. A lot of people will tell you there aren't three pillars, that this is, et cetera. But I think it's a really easy way to reason about the kind of state of the world in which we see it. Observability, we define it as the ability to ask and answer questions you did not plan in advance based on data coming out of your systems. And that's incredibly important, because the data fundamentally has to get out of the system for us to introspect it. And there's really kind of three classes of data. So when the people say there are three pillars, this really has more to do with how the data ends up needing to be stored and accessed so that we can actually reason about our systems. The first is metrics. So generally, metrics are what's going to tell me, like, do I have a problem? It is a measurement at a point in time whereby which I'm saying, hey, right now the temperature in this room is 72 degrees. Logs help me understand what problem I have, and logs are a series of events serialized to some sort of file, right? So an event is the temperature was changed on my thermostat from 72 to 80 degrees, or down to 68 degrees. And then lastly, from a tracing perspective, okay, I know the temperature was changed, but it did not succeed. So changing the temperature actually has a large number of things that actually happened below the scenes. There was an event, a log entry may say a user did this thing, but once the user did that thing, it then interacted with dozens of potential components to actually change that temperature. So when I change that temperature, let's say that I changed it from 72 to 80 and the temperature doesn't go up. Well, why not? There's a large number of trace points that I need to understand. I may need to go troubleshoot inside of the HVAC system. I may need to I may need to troubleshoot out of the thermostat itself. And the traces are going to give the troubleshooter specific details about every component in the system to understand how they're performing. And ultimately, what they're going to end up answering for you is, which portion of my subsystem do I need to go look at? Which developer do I need to call? Meanwhile, things are not the same in security as well. And so, in our business, the data sources that we work on, we see spread across IT, DevOps, SRE, and security equally well. And in the security world, we're seeing kind of three major trends which are driving the need for something like an observability pipeline. The first is the shift to cloud. Everything about securing the cloud is different than securing on premises. From the data sources, I need to be able to integrate large numbers of new types of logs like CloudTrail. I need to be able to understand new interactions like IAM and permissions. And so security is just fundamentally struggling with how do I secure SaaS? How do I secure just a very different world than I emerged into? Additionally, new compliance regimes are driving significant change into security tooling. So, for example, GDPR in California's CCPA, which is just coming into effect in recent months are starting to make us ask questions of how do I even comply with these regimes? If I have PII or even potentially entity identifiable information in my logs or other security relevant data, am I compliant with GDPR or CCPA? And so we have a strong problem with needing to adapt to new compliance regimes that are coming in. Lastly, for the last decade, there's a new breach in the news every few years, or maybe even every few months. And for any organization that is attempting to secure their modern enterprise, breaches, the notification tends to happen months after the actual incident. So how can I go back and look back in time and understand the impact of this breach? So if there was lateral movement, like to which systems? Well, did I keep that data? Do I have data from 6 months ago or a year ago or 2 years ago, which can answer questions like what my exposure was in the event of a breach? And so security teams are having to answer, all of these fundamental new challenges. And that's leading to a large number of net new players in the market. On the security side, threat intelligence feeds, endpoint security, the number of tooling in the security world is increasing linearly to exponentially. There's just a lot of people that are playing in the space, and they're not doing it for no reason. These solve very, very real challenges that security teams are living with. And the same thing on the IT and SRE side. Monitoring, logging, tracing, the chaos engineering, the number of new tools emerging into this marketplace is creating some interesting swivel chair problems, whereby which as a user, I'm having to kind of look through a number of different tools in order to answer basic questions about my environment. Okay, so what? So the world is changing. Why do I care? The first reason is cost. Operating large amounts of tooling is very, very expensive. We know we have customers that are spending tens of millions on infrastructure alone just to run logging systems. We have customers that are spending millions on their SIEM and security tooling. And so there's always a back pressure from the business to say, we can't afford, for example, in the case of a breach investigation, I can't afford to save every flow log forever. As a simple example, we think you can actually, but not in the systems that are generally used for that today. And the last problem that this is creating is a ton of complexity, which is kind of where we're going to go into next and talk a little bit about how the current tooling ends up really looking today when you add together all the tools that you're going to need to operate and secure your environment. So the current state of kind of data flow in this world is incredibly complex. At the left-hand side, this is an endpoint. One particular container or VM or OS instance potentially has dozens of agents, all talking to relatively proprietary ingestion pipelines. So let's walk through these just in a little bit more detail. So assuming you have a log analytics tool, most people do. That's a Splunk or an Elasticsearch where I'm dumping raw text log files in for search. When we start in the world, I have a log shipper and I glue it up to my log analytics tool, and for the most part that works and life is good. But then when you start examining the other data sources we need to onboard, the world gets a little bit more complex. So if I also need to get in data from my network devices, I'm going to probably stand up a separate syslog receiver, which may have another log shipper that's reading files that the syslog receiver is writing to disk. And you start to see the advent of these ancillary tools or ancillary infrastructure, extra infrastructure that I have to run. So you think you're getting a solution in a log analytics tool, then you realize suddenly that I actually have to run not only a syslog server, but I also need to run a separate kind of middleware to receive HTTP coming out of my applications where I can't put a log shipper sitting right next to it, or I don't want to write log files to disk. If I want to collect from REST APIs, let's say I want to get data out of Microsoft Office 365, I'm going to run another API collector, which is, again, another piece of software that's going to go out and scrape data and then write data to my log analytics tool. And then when we start getting into the big data side, we're actually duplicating a lot of this infrastructure, right? So oftentimes you'll see the business team or the security team, maybe they're creating a security data lake, we'll install a separate log shipper to also write that out to a Kafka or write that out to a data lake like an S3 or a Snowflake. And then you may also want data coming off of your event bus to get it into your log analytics tool. So there's another piece of infrastructure that you're probably running that's sucking data out of your Kafka bus and pushing it into your log analytics tool. And you'll start to see this just continue to the connectivity required between the SIM tool is actually going to feed out of the log analytics tool. So there's another little piece there. And when we get into the metrics, there's a whole nother agent and a whole nother set of pipelines on the time series database side and connectivity between log analytics and the time series database. And then as we get into APM, yet another proprietary tooling, also gathering, largely the same amounts of data. And so we believe fundamentally that this can be done significantly better. And so I'll talk a little bit about an observability pipeline and how we think that this will make the world a better place. The first thing about an observability pipeline is it's a universal receiver. And so all of your existing agents that exist out in the world, whether that's a Splunk Universal Forwarder or an Elastic's Beats agent or a FluentD, or maybe your metrics agent like a Telegraph or your proprietary SIM agents, the goal, or APM type of data, the goal is to be able to, anything that's pushing data at one of the destination systems, the pipeline can receive that data and process it. And we'll cover processing in just a minute. Additionally, and this is an important new concept, and this is new even for Cribble, this is an area that we're coming, that we have some exciting announcements in the next few weeks about the ability to also be a universal collector. And so a universal collector also needs to be able to reach out and scrape REST APIs. It needs to be able to reach out to network devices and gather data from network protocols. But possibly most importantly, it also needs to be able to reach out to cheap storage like your data lake and be able to bring data back to the front of the pipeline for eventual delivery to any of the destination systems that we may support. And so that's things like taking data from a data lake, writing it to a data lake, taking data from a data lake, writing it to an event bus, taking data from a log analytics tool and putting it on the event bus. Collecting data allows us to reach out to data that's already at rest, bring it to the front of the pipeline, and process that data in new and different ways. And fundamentally, an observability pipeline, first and foremost, allows us to connect any source to any destination. So let's say, for example, that I have a project and someone's saying, hey, this other, I'm a Splunk shop and this other team has come to me and said, I run Elastic, but I also want to get the data into Elastic. I have a team that prefers to use that tool. I have my Splunk Universal Forwarder. It's deployed out to 100,000 places. I don't necessarily want to roll out a new agent that's going to collect the same data. I can take that Splunk Universal Forwarder and I can connect it up to Elasticsearch, or vice versa. I can take a Elastic Beats agent and I can make it talk to Splunk. I can also take data coming out of something like a Splunk Universal Forwarder. I can process it, enrich it, aggregate it, and put it into a time series database. A lot of log type of data is actually metric data. It's saying this thing, this measurement happened at this point in time, along with these other things that describe that measurement. That might be a better fit for a time series database. I might be able to much more cost effectively understand the performance of my systems by loading all of this data into a TSDB. And so fundamentally, an observability pipeline allows you to connect any of these sources or collect from any of these sources and connect it to any of these destinations. And the big capability that this allows you to do is to separate your systems of analyses from your system of record. And so in a lot of cases, especially in security shops, we see people using a log analytics tool as an example as their system of record. In case of a breach investigation, in case of compliance, in case of litigation hold, I need to go back to this place and this is the place where I'm going to go get all of my information from. And that's not wrong. And in fact, this is probably one of the better ways to do this today, but it drives a lot of cost. Storing, years worth of log data in an inverted index when I'm not even going to query it because I'm really holding on to it in case I need it later. It's much better fit for an object store like an S3. And I just want to be able to plow all my raw data into my data lake or into my object store. But historically, a lot of people are doing this. I mean, we see this everywhere where people are just putting, huge volumes of data into S3 buckets for potential later analysis. But the biggest problem that then creates is like, once the data is at rest in S3, what do I use to analyze it? There are some tools on the market. You can use things like Athena. You can use, Snowflake and other great partner technologies. But usually that data then needs to be structured first. So you can do that parsing and structuring of the data in the pipeline before it ends up landing in that data lake, opening up to analysis from other systems. But then also you can lay all that data down, and with our collection capabilities, then be able to suck the data back out of something like an S3 and deliver it to a log analytics tool for investigation at a much, much later date. You can also do the same thing for long, let's say I have a year's worth of weblog type of data that's stored as events in an S3 bucket. I can take and suck those out, do an aggregation or analysis, and feed that into a time series database for analysis. So being able to separate out that system of record and having a very, very cost-effective place to land all the data fundamentally changes the entire perspective of how you're managing your observability and machine data. And lastly, what that allows you to do is eliminate a lot of noisy data. So half the data that you're putting into a log analytics tool today is junk. It's just not particularly interesting. Now, a lot of security people that we talk to, one of the biggest problems is, well, what if I eliminated noisy data that actually wasn't noise? What do I do? That's where separating your system of analysis from your system of record is so critical. If you can have an affordable place where you can actually keep all the data, then you can be very selective about putting only the data into your log analytics tool that's worthy of analysis, or data into your time series database that's worthy of analysis. And so fundamentally, you can get rid of lots and lots of data that may not be of interest to you. So probably the most frequent question that I get, because this is a new category, observability pipelines didn't exist before recently. Isn't this just, Kafka? Like, I've got a Kafka team over there. They're onboarding lots and lots of different data sources. Can't I just solve this by throwing my observability data onto my event streaming platform? The answer is yes, you actually could solve it that way, but it is not, Kafka itself or your event streaming platform itself is not the solution to this problem. The observability pipeline can run on top or encompass something that is an event streaming platform, but an observability pipeline has a number of properties above and beyond simply reliable data delivery from source to destination. So first is protocol support. So I need to work with all of my existing agents. If I have 100,000 Splunk forwarders, if I have 200,000 Elastic Beats agents, I need to be able to use that same data collection infrastructure to service multiple use cases. I don't want to have to roll out a whole new agent every time there's a new tool in my observability portfolio, a new tool in my security portfolio. It also needs to collect from those existing systems as well. Secondly, and this is an underappreciated aspect of this particular problem and why observability and observability pipelines are different than just an event streaming platform. Data coming out of logging systems in particular, it's ugly. It is unstructured. It was written probably not for the purpose you're actually even using it. It was oftentimes a developer's output for troubleshooting or other particular reasons. And so in order for us to analyze that data, oftentimes there's some parsing steps, there's dealing with many nested types of data structures. And so anybody who's worked extensively in the logging world will have seen ugly logs where we have to, we've got JSON encoded in ArcSight Ceph. And we need to extract that JSON. We need to be able to parse that JSON. We need to restructure the data and get it into something that will do well in a Snowflake or into an Athena or into a Databricks. And on top of that, and this is probably the most underappreciated portion of the problem that needs to be solved, is that in an observability system, the first use case is I just got to connect this existing pipeline to all of these destinations. And I don't get to control the data shapes. So if you look at a standard security logging or IT operations logging tool, they will have tens of thousands of different data shapes. Just go into your Mac and just look at your system log, or go look at a Linux box and go look at var log messages, and each one of those entries has a different potential data shape that needs parsing and understanding. And so we're not getting well-structured BI type of data. We're getting whatever data gets thrown at us, and we have to be able to deal with the data as it comes to us in whatever shape it happens to come to us as. Thirdly, that's different about an observability pipeline system is around scale. In our larger customers, people are moving hundreds of terabytes of data a day. There are installations that are moving tens of petabytes of data a day that we have heard of. Typically, most event streaming platforms are moving terabytes a day. That doesn't mean they can't scale. I've heard of Kafka installations scaling up very, very large. But in you don't necessarily, Kafka writes everything to disk. And so from a scale perspective, you may need to make trade-offs in an observability pipeline about, okay, I want some of this to go to disk. I want some of this to be buffered. Some of it I have more tolerance for, or I really just need to get the data in and get the data out. And so scaling these things up requires a strong focus on efficiency and scale. And as an example, we test our software into the 20 plus petabytes a day. It also needs to support hundreds of thousands to potentially millions of endpoints also writing. So not only does it need to handle large volumes of data, it also needs to handle very, very large numbers of connections as well. And so since you're here, you probably have guessed that we have a solution to this problem. So our product is called Cribble LogStream. We are an observability pipeline. There are other observability pipelines out in the world. People have built this on top of open source, or they have custom engineered their own solutions. We are a solution that solves this problem out of the box. A single tarball can be scaled from your laptop up to petabytes a day. It's a simple download from our website. We support and try, if there's things that we don't support, we add new integrations with every release. We support all the major sources and destinations in the system. We support Splunk, we support Kafka, we support syslog. The syslog is by far the largest kind of second data source that we see in the world. We support a number of different destinations, from Splunk to InfluxDB. As an example, the being able to take, for example, high volume log data sources like web logs or flow logs that are actually really much more measurements. There's potentially massive savings converting logs to metrics and storing it in a time series database like an InfluxDB, or even, Elastic also has some time series database components in there. You can save yourself huge amounts of money by storing data in a much more efficient format. And that's one of the key capabilities of an observability pipeline, is this ability to process, enrich, and route and control all of that data and choose where that data is going to go. So we've been out there, we've written, or I have at least a number of articles on what is an observability pipeline. We will follow up the webinar with links to our writing, as well as writing from Tyler Treat at Real Kinetic, who actually coined the term observability pipeline. Corey Watson, who's actually now at Splunk, I think, via Signal FX, has written about observability pipelines. So we're not the only ones out in the world talking about what an observability pipeline is. But I think, we didn't invent the term, but I think it really does describe our use case pretty perfectly. We do this for our customers. Cribble is a customer-first company. We love our customers. We sell to some of the largest enterprises, and we also sell to very, very small shops as well. So this is a problem all the way up and down the stack. And we've got a lot of really great customers and customer use cases, and the customers teach us new things every day about where we can go to get new insights about new use cases. So to summarize, and we'll have time for Q&A at the end, I hope that this matches what I said, which is enterprises need a lot of tools to operate and secure their businesses. These tools are very big and hard to manage and hard to run. They are very expensive. An observability pipeline allows us to process all that data before storage and potentially save you millions of dollars and greatly simplify your environment and simplify your complexity. So with that, I will pause for Q&A. We have a Q&A feature at the bottom. So if you go to the bottom of your screen, there is a Q&A feature. If you have a question, some of you have already asked a few questions. Thank you very much. If you have a question, could be about anything, a use case, does it work with this? How does it work? Pop it down there in Q&A, and we'll either answer it live or we'll get back to you after the webinar. Okay, cool. I see a couple of questions. How is Cribble different from FluentD? That's a great question. FluentD is an open source tool for doing log processing. You see it deployed as an agent. You see it's sponsored by the CNCF. So I think there's a number of attributes of our product which are incredibly important. The first is that it is a managed distributed system. So in most enterprises, you're going to be deploying this as a distributed system. So if I'm pointing hundreds of thousands of agents at a centralized platform, I need to be able to manage the thing. I need to be able to configure it. I need to be able to monitor it. I need to be able to understand who's making change and what change that they're making. Secondly, performance. So there's some posts on our blog. We're significantly more performant. FluentD, I've heard they've improved in recent years, but the thing I hear most frequently, I don't use it personally that much, but the thing I hear most often is that it is it causes, it is not particularly performant. In our testing, I think we're something like 5.5 or 7x faster than FluentD. And then lastly, in addition to management and monitoring, it's the user experience of how do I develop these pipelines. I've used FluentD to some extent. I've used Logstash to some extent. And the workflow there typically is something like, hey, on my laptop, I stand up an instance and I cat some data through it. And I kind of hope that works. In Cribble LogStream, everything is graphical. Everything is interactive. And so I'm working with captured samples of data. I'm making sure that the data gets shaped up right. I can integrate that with my GitOps workflow so that I can review those changes. And it is a full enterprise solution to that particular problem. So that's how I would say we differentiate. Let's see. We have a few other questions. Do we have, so a question is, do you have any use cases customers who are using Cribble to source or target business data platforms? It happens occasionally. It's not the target that we focus at. There's a lot of people in the streams processing market. And while I think we're probably equally applicable to business type of data, we don't tend to target that. So I'm sure we can find some people in our customer base who are doing this, but it's not an area, it's not a very frequent use case. Usually we find there's a lot of other products out there that we see more on the business side, and we don't tend to target that. Do we have an NFR license for developers? Absolutely. You can actually just go grab the product, go to the webpage, go download. If you complete our sandbox about once a month, we'll send you a license that's a 1-year license. So as a next step, I highly recommend you check out our online sandbox, our fundamentals course. So if you go to sandbox.cribble.io, the fundamentals course will walk you through. It'll take you about an hour to 2 hours through a number of different use cases. And let's see, complete this. Yep. So you'll get it. We're going to send out this month's licenses in the next couple of days. So we'll send that out. But FYI, there's always a free license that's available to you. Every time you download the product, the latest version, the free license is out there for the next 3 months. So the NFR is nice in terms of like you won't have to upgrade quite as frequently, but there's always a free entitlement out there to go about testing out the product. So another question is, how is Cribble LogStream different from NiFi in terms of performance and supportability? It's a great question. So NiFi also has sort of a centralized GUI and management, so great on them. It's actually kind of a really interesting product. I like it. Generic streams processing engines tend to be targeted, have a very different workflow and tend to be targeted at a different persona. So NiFi is a streams processing engine targeted at developers who want to build a streams processing application. And the workflow is all around, I'm going to take a single type of data, and you can see it in their canvas. I drop a source on it, and I'm going to connect this source to this destination. Whereas in an observability pipeline, the workflow is completely different. My first use case is I just need to get this fire hose from here to here, and then I'm going to start thinking about what data I want to manipulate. So it's a very different workflow. It's also very different in terms of scale. The NiFi and other systems tend to be built for terabyte scale, and we tend to be built for petabyte scale. Not insulting that they're solving the business problem in the way in which they need to solve it. It's not a problem for them. It's a different problem in logging types of systems. So different UX, a very different performance. Say, I noticed you have integrations with AWS and Azure. Do you have any plans to support any of the GCP services? Please contact us offline. All things at Cribble are driven by customers and prospects to some extent, but primarily customers. And so if you have a need for that stuff, then absolutely, we'd love to support you. I haven't seen a lot of GCP customers in the field yet, and so we're really just looking for the first couple of Lighthouse customers to go there. If you have a need, then we're certainly interested. How is the integration done with Splunk, and what does Splunk change its protocol? I worked at Splunk for a very long time. The protocol that's been used between the forwarders and the indexers has been the same for a decade. They've re-implemented the same protocol inside of their streams processing engine. That protocol, even if they did change, we would be able to support it. We're a partner with them. We would be able to update to the latest version. There's been no friction with them. They're not trying to keep us out of their ecosystem. That protocol is proprietary, but it's well known and well established. There are open source implementations of it if you go looking in the right places. The risk of them changing protocol is basically nil, because they would also have to update all of their own stuff as well. And you'll also see them, I think they're going to start moving to more open protocols over the course of time anyway. I don't think that protocol is going to stay proprietary forever. Let's see. Our security team is interested in enriching logs and events with records. Yes, absolutely. We've got, and I can, do you have customers who have done this? Absolutely. In fact, I think we have a similar one, which is a little bit more about, so this is more about, where was this one at?
I think it's the first one.
Oh, first one. I skipped it. There we go. So this was more about enriching against known DNS top 1,000 lists to basically say, hey, if it's on the top 1,000 list, it's not security relevant. So I just want to use that to filter out the data. Threat lists very similar. We've got examples of people doing threat scoring and things like this, enriching the data in flight. So very, very popular use case. Somebody asked about open source tools. I talked quite a bit about that. How do you make sure that there is no event loss? We do not drop data. So there's no code path, with the exception of underlying, like if we send it UDP or something like that, well, we don't control that, but there's no code path inside of LogStream whereby which data is discarded unless you've expressly told us that that destination is designed, is set to drop on back pressure, et cetera. So there is no loss because we built the system for, at least once reliable delivery. So, we test this extensively. We have package testing that runs against all of our known integrations on every build. To some extent, you have to trust us that we've built this type of software for a very long time, and we have built it expressly not to lose data. It just doesn't. Cool. So let's see. Can you talk about the kinds of data volume reduction and other benefits? Yeah, absolutely. Typically in most organizations in aggregate, the easy gains are something like 25% plus savings. In terms of just getting rid of noise, et cetera. If you're doing things like aggregating logs to metrics and other types of sources, those can be even more dramatic. You can, a very large event data source serialized as a metric could potentially be, 80, 90% smaller, depending on the cardinality of the data and how you do the aggregations, et cetera. So your mileage may vary, but the savings are significant. The way we're doing things today is very inefficient, and there's significant gains to be had. Let's see. Are any customers using Cribble as a universal receiver when migrating from data platform to data platform? Migrations from ArcSight to Splunk I've done previously come to mind. Saves a lot of hassle when you don't need to install. Yeah, absolutely. And we have a Ceph serializer in there as well. So you can stick us in the middle between your existing syslog producing Ceph sources and ArcSight, and then tee the data off to something else, or in between Splunk if you're trying to also send the data to an Exabeam or something like this. It's a very, very frequent use case. And in fact, alleviating agent fatigue and giving you portability and avoiding vendor lock-in is one of the key selling points that we have to enterprises, is that we are the only vendor agnostic, observability pipeline on the market today. And we're really giving you that kind of portability and the ability to pick and choose tools, as you see fit. Can you do a correlation between different source streams, metrics with logs and traces? Not today. We do not do that level of analysis. Will be things that we'll go into over the course of the next year. But there's no cross-event correlation available today. There are ways that we can engineer a solution using other databases or event streaming platforms that might solve that particular problem. But it is that's something that'll be coming sort of over the course of the last year. Any other questions? Those have been phenomenal questions. Thanks, everybody. Let's see. Can you tell us something more about the pull data feature upcoming? Absolutely. So back to our handy dandy slide, and I don't want to preview our 2.2 release too hugely, but coming out in the next version is an ability to collect from S3 on demand ad hoc. So in 2.2 we'll have ad hoc data collection, in 2.3 we'll have scheduled data collection. In addition to data lakes and others, this is really a universal data collection feature to collect from any type of source. Imagine things like SSHing into a bunch of boxes or scraping REST APIs. So without going into too much detail, because I don't want to derail on a 2.2 launch webinar, but we believe that this collection capability is transformational. It is the introduction of batch into logging, and logging has always been a streaming problem. This is, we think, the first purpose-built batch system for logs. And will really enable you to back to collecting, using that data lake like a spool, like a place where I want to toss some data temporarily and be able to get back at it. So super, super critical. If you think that's important, please reach out to us. We are, getting this out to beta customers, in the very near time frame. What is the latency added from source ingestion, collection to delivery? It's measured in microseconds. So essentially, the data that's coming in the front side and going out the back side, we're adding, like I say, microsecond latency. So we don't go to disk. Everything that comes in the wire and goes immediately out the wire unless the destination is offline. And so it's basically the time required to read the data off the wire, parse it, structure it, etc. I keep clicking things. And then write it out to that per particular destination. So can you talk a little bit about your strategic partners, and you can tell us a little bit about upcoming hotness, AWS, Elastic, etc. Yeah, so we've got great partnerships with all the people in the space: Splunk, Elastic, AWS. InfluxDB is one that I'm working on right now, which I think is super cool. You'll see a blog post from us in the next week or two where we talk about feeding Cribble's internal metrics, for example, out to InfluxDB. I think having a strong time series database platform is incredibly critical for your cost management in this ecosystem, since a lot of this data is really just time series data to begin with. And on the AWS front, previewing a little bit of things that are coming in the future, we will have, hopefully within the next 3 months or so, an offering in their marketplace. So if you are interested in an on-demand offering of Cribble LogStream, please reach out to us. We're looking for early adopters today. And our goal is really to give you, buy the drink processing where you're paying only for the infrastructure that's running. The biggest news on the AWS front is getting that on-demand offering, and if that's something that you're in the market for, and you want something that's in AWS Marketplace that you can pay for by the hour, we're working on it, and we would love to talk to you.
So I think we've gotten to the questions.
One more. Let's see. Is the So is the primary interface to manipulate events through UI, or are there APIs and clients for automation? The answer is both. The primary interface is through the UI. There are APIs and there are abilities to automate this through the CLI, through the APIs. We generally recommend the UI for generating configurations. This is another one of those differentiators versus something like a FluentD or others. Config files are not the UX that software should be giving you in today's world. And it's, to get in a little bit on my high horse, I think it's kind of a travesty that the world has gone to, hey, the way in which you interface with me is via YAML. YAML's great. I just shouldn't have to type it out by hand. and we provide you a rich user experience for generating that YAML, while at the same time integrating with source code control, with your existing GitOps flows, and trying to make sure that we fit into a world that is a config file world, while giving you a user experience that is top notch and top notch. One more question, and then we'll wrap it up. We're starting to move to Elastic and need to do some pre-processing. Can this help me avoid having to run Logstash? Absolutely. So we are analogous to a Logstash or a Splunk Heavy Forwarder. We can do the parsing in the pipeline. So even if you've got a Splunk Universal Forwarder that's just outputting a byte stream, we can do the parsing and enrichment and all the functions that you would have been doing in Logstash. We can do that in LogStream with a rich centralized user experience and designed to be managed at enterprise scale. So absolutely, we can fill that role for you, and we've got customers that are doing it today. Cool, man, phenomenal questions. Really good. I think the questions were better than the presentation. Cool. I think Brian, back over to you.
Thank you, Clint. Thank you, everyone, for attending today. That will conclude our webinar. Please check the email that you used to register for the event for a link to the recording of this webinar. And again, I encourage you to visit cribble.io/events to see information on upcoming events. Thank you, and have a great day.